All right, what's good, everybody? This will be our first statistics lesson. Okay, chapter 1, lesson 1. Today is going to be a brief overview of what statistics is, and we're going to talk about data collecting. Okay, you should get a set of notes in class. These notes are different than what I typically do for notes, especially if you've had me in years previous. Now that this is a statistics class, now that this is a class that you have chosen to take, it's not a required math class. We are trying to make it more like a college class, where I'm not telling you what to write. I give little questions or things in the margins, but honestly, everything is up to you, right? The more detailed that your notes are, the better they will be later on when you're trying to study for quizzes and tests and things like that. Okay, so notes are completely up to you to fill in and make as detailed as possible. Okay, if we were in class, I'd take this time to go over and review Google Classroom. The way that the Google Classroom is set up, if you want to go in there yourself right now, there will be 2 sections for every chapter. It'll be chapter blank material and then chapter blank solutions. Okay, in the chapter material, it'll be all of the lessons and the notes. In the solutions, it will obviously be the solutions to the homework problems. Okay, again, doing this as a video, it's a little bit different than it was in class, but I want you to think, what is statistics? If we were in class, we'd have a discussion. I want to get answers and things like that. Obviously, it's a video, so it's a little bit different. And if you were an extremely intelligent person and you have your notes in front of you, you would have seen that the definition of statistics is actually on your paper right there in front of you. Statistics is the science and art of collecting, analyzing, and drawing conclusions from data. Okay, so today's lesson is data collection, right? We're going to talk about how we can collect data, how we can analyze data, and how we can draw conclusions from that data. Okay, our first example is an activity called 1 in 6 wins game. Okay, this activity gives you a taste of what statistics is, drawing conclusions from data. Okay, as a special promotion for 20-ounce bottles of soda, a soft drink company printed a message on the inside of each bottle cap. Some of the caps said, "Please try again," while others said, "You are a winner." The company advertised the promotion with the slogan, 1 in 6 wins a prize. The prize is a free bottle of soda. Okay, so Jorge's statistics class wonders if the company's claim holds true at a nearby convenience store. They're seeing if they are telling the truth or if this company is lying to you. To find out, all 30 students in the class go to the store. Each of them buy a bottle of soda. Only 2 of them get a cap that says, "You're a winner." Does this result give convincing evidence that the company's 1 in 6 claim is false? You and your classmates will perform a simulation to help answer this question. For now, let's assume that the company is telling the truth and that every 20-ounce bottle of soda it fills has that 1 in 6 chance of getting a cap that says you're a winner. Okay, we will model the status of an individual bottle with either a 6-sided die or using a random number generator on your calculator. Okay, let the numbers 1 through 5 represent "Please try again," and let the number 6 represent "You are a winner." Okay, so let's first talk, all right, before we even start doing the dice and whatnot, right? What is the probability of wins in Jorge's class? Well, we know that 2 people won, and we know that there's 30 students, so that means that probability is 2 out of 30. But if we simplify that, that means it simplifies down to 1 out of 15. Is this probability higher or lower than what the company claims? Well, is 1 out of 15 higher or lower than the odds of getting 1 in 6? 1 in 15 is much lower, so the first part of that question is that it is lower than what the company claims. How many students should have won if the company was if it matched what the company's claim was, right? Well, 1 in 6, and there's 30. What do we have to multiply 6 by to get to 30? By 5. 1 times 5 would be 5. So we should have had 5 wins. We only had 2. which again means that it's lower. Okay, so based off of this information, should we reject the company's claim? Why or why not? I'll let you decide that, okay? Now we are going to simulate this and decide based off of our information whether or not we should reject the company's claim or believe that they are telling the truth or not. And again, I'm not in class right now. We're not in class, so you will be doing this in class. Okay, you will be using a dice. You're going to roll the dice 15 times, and then you're going to be using the calculators to do just a random number generator. And again, a reminder, numbers 1 through 5 are losses. Number 6 is a success. Okay, so you're going to roll the dice 15 times, tally how many times you get a win or a loss, and then you're going to use the calculator to do a random number generator. Again, the instructions to the calculator are there on the screen. First, you're going to hit the math button right here, right? Math button here. Then you're going to hit probability here. Then you're going to go to number 5, random integer. Okay, you're going to put your min as 1. You're going to put your max as 6. You're going to hit enter. It'll give you a number between 1 and 6, and you're going to repeat that process 15 times. Again, not doing this in class, doing this over a video, right? If we were in class, we'd create a class results of, or a spreadsheet, sorry, a dot plot of the class results of each person of how many times that they got a certain amount of wins. Okay, so if you did your results 30 times, how many of those 30 times did you win? Okay, we would make that of if you won 0 times, 0 times, 1 time, 2 time, 3 time, 4 time, 5 time, blah, 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 blah. And then we'd go through and count each student. Okay, student 1 said that they lost 1 time, so I'd put a dot here. Student 2 said that they won 4 times, so I'd put a dot here. Student 3 said they won 27 times, so I'd put a dot there. Then the next student said they also won 4, and then the next one won 1, and the next one won 2, and the next one won 5, and the next one won 3, or 2 and 3, and so on and so on and so forth. And we would create a dot plot if we were in class, okay, to see what people are getting randomly as their results. Oh, sorry. And then after we would complete that, we would say what percent of simulations only had 2 or less wins. Does that give good evidence that the company is telling the truth, or does that give good evidence that the company was lying? Or does it give good evidence that Jorge's class potentially just was unlucky in that instance, and so on? Okay, these are the questions that we need to ask ourselves, which leads us into our problem-solving process. We need to ask questions, we need to collect data, we need to analyze that data, and then we need to interpret the results. And again, we've done that, right? We are asking questions, is this soda company telling the truth? We collect data by going to the store, buying sodas, or in this case, flipping, rolling dice and doing random numbers. Then we analyze that data. That's where we did the dot plot. Now it's up to you to interpret those results. Okay, moving on. The way that we classify data, the table displays data on several roller coasters that have opened since April 2014. Okay, we're going to come back, but we're going to identify the individuals and the variables in the table above. Well, what is an individual? What is a variable? I am glad that you asked that question. Hey, an individual is a person, animal, or thing described in a set of data, right? Think of it, this is also sometimes called subjects. And a variable is any attribute that can take different values for different individuals, okay? Now, with variables, there's 2 types of variables. There's categorical variables and there's quantitative variables. Categorical variables assigned labels that place individuals into particular groups. Okay, you can categorical is also sometimes called qualitative. You're describing the quality of something, whereas a quantitative variable takes number values for which it makes sense to find an average. Okay, so we're going to go back up to that previous table, and we're going to take a look, and we're going to think which of these are individuals, which of these are variables, and then even more further, what type of variables are they? Okay. Well, the roller coasters, those would be our examples of our individuals. The type of roller coaster, the height, the design, the speed, and the durations, these are all of our variables. Okay, now going back, let's think what type of variables are they? Are these categorical or are these quantitative? Okay, the type, would you put that into a category, or is it something that you would count and create an average? That's a categorical. Height, that's a number. It's easy to average. That would be a quantitative variable. The design, is it sit down, inverted, etc., right? That is a categorical variable. The speed and the duration, both are numbers, both make sense to average them, so those would be quantitative variables. Okay, now I wanted to make a note. Not every variable that takes number values is automatically quantitative. For example, zip code. Zip codes are numbers, but when we talk about zip codes, that refers to an area. It doesn't make any sense to talk about an average zip code because that does not exist. Okay, it's just based off of location. So even though it's a number, it's still a categorical variable. Okay, other examples would be like room numbers here on campus, right? I'm in room 119. That's just a place, right? You're never gonna take the average number of the room numbers, okay? So make sure that it's quantitative is more about thinking about if it makes sense to average it or not. Okay, our next example problem. The American Statistical Association sponsors a web-based project that collects data about primary and secondary school students using surveys. We use the site's random sampler to choose 40 U.S. high school students to complete a survey. The survey asks the question, which would you prefer to be? Rich, happy, famous, or healthy? Okay, before we get into it, I just like collecting data ourselves as a class. What do you think will be the highest response? What do you think will be the lowest response? Why? What would you choose? Okay, again, if we were in class, we would actually collect all this data and we'd write it up. But since we're watching the video, we can't do that. Okay, anyways, here's the data on the preferred status for all 40 students from the previous question. Okay, there's 40 responses, some famous, some healthy, some happy, some rich. Okay, summarize the distribution of preferred status with a frequency table and a relative frequency table. Okay. Also, we need to know what the word distribution is. Okay, there's a space for you to write distribution there on the side. Here's the definition of distribution. It describes the pattern of variation. When we create frequency and relative frequency tables, okay, think frequency shows the number of individuals having each data value, and a relative frequency table shows the proportion or percent of individuals having each data value. So think frequency is the number, relative frequency is the percent or proportion. Okay, so I'm looking here. All right, notice there's a column for tally, just because that makes it a little bit easier to count them up as you're going through. Okay, so if we go through, we just keep a tally of what responses are where. Okay, I'm not going to spend the time of doing all the tallies. You please spend that time to do it. You end up finding that 7 people chose famous, 21 people chose happy, 4 people chose healthy, and 8 people chose rich. And if you need to confirm, you add them all together, and you do indeed find that you have 40 answers there. Okay, so remember, frequency is the number. 7 people chose famous, 21 happy, 4 healthy, and 8 rich. Okay, now, next, we need to have the relative frequency. Remember, relative frequency is proportion or percentage. How do we change a frequency into a relative frequency? We just change it to a fraction and divide and change it to a decimal, which means that we can then change that to a percentage. So 7 out of 40 people chose famous. If we divide that, that gives us a decimal of 0.175. And if we move the decimal 2 places to create a percentage, that's 17.5%. Okay, 21 out of 40 people chose happy, which becomes 0.525, which is 52.5%. 4 people chose healthy, 4 out of 40, which is 0.100, which becomes 10%. And finally, 8 out of 40 people chose rich, which is 0.200, which becomes 20%. Okay, and again, if you're unsure, you can add all of these up. If you add up all these decimals, it does in fact come out to 1.0. If you add up all these percentages, it does in fact come out to 100%. So that way we know. Okay, on your own. I'm going to let you do this on your own because, that's what it says. On the first day of the statistics course, the instructor gave all 40 students in the class a survey. The table shows the data from the first 10 students on the class roster. Okay, I want you to go ahead and answer these questions. What are the individuals? What are the variables? Then classify each variable as categorical or quantitative. Okay, here are also the ages of the 40 students. Summarize the distribution of an age with a frequency table and a relative frequency table. I just went ahead and put both of them in the same table just to save space. Okay, and you can write this on your paper and go ahead and fill that out. Okay, next, once we finish with that, you're going to work on your homework. You're going to use the online textbook. Remember, your pacing guide is posted in Google Classroom. The pacing guide shows you what numbers you are working on. I'll be sure to go over with you with this in class. Great first lesson. Welcome back. Go team.